Okay. So our topic next is what you call the spacing of fasteners in built up. Oops, nagkakaganon. In built up sections. Okay. Unahin natin, ano yung fasteners na tinatawag. So, tinatawag yung mga bolts o kaya mga rivets. No? Pag sinabi nating built-up sections, for example, meron akong wood plank. Yung una nating example, let's say yan yung beam mo na wood plank. Tapos, meron kang patong-patong. Okay. So, sabi ko nga, para mag-act siya as one, dapat meron sa kanyang nag-hold. Okay. So, pwedeng yan, lalagyan din ng bolt. Lalagyan dyan ng bolt. Okay. Lagyan dito ng bolt. Oops. Yan. Lagyan dito ng bolt. Okay. Kasi sabi ko nga meron dong may nag-i-slide, di ba? So merong sliding effect, so meron dong mga forces. Okay, so may mga forces dun. So instead para hindi siya mag-deform, so ang nag-absorb ng forces na yon ay yung mga fasteners. Okay, so ito it's either bolts or fasteners. Na tinatawag fasteners or rivets. Okay? So, may mga spacing siya. Okay, so you have there the spacing. Okay, so the general formula for the spacing S would be equal to R I over V Q. Okay, so moment of inertia. Okay, statical moment of area kung saan later on kung alin yung matatanggal na area, yun yung kukunin nating moment of area niya. And then the shear force. Okay, so shear force on that section, or normally the maximum shear force. And then the R, this is the capacity of fasteners. It's either kilonewton or pound. Okay, so dapat siya force. Okay, so RI over VQ. Dun sa other books, kay Paitel and Cusalas, same lang yon, kaya lang nabago lang yung notation niya, baka malito kayo, I all over VQ. Okay, same lang yun, wherein the E is the spacing, and then the FW is the force on the fasteners. Okay? So, yung spacings na yon, for example, okay, ayan yung plank of wood mo, okay, 83 din natin. For example, you have there the plank of wood. Okay. And then that is simply supported. So let's say simply supported ka. And then nandito yung mga bolts mo. Okay? So you have there your bolts. Okay? So yan. You have there your bolts. Okay? So itong mga to, okay, iyan yung kino-compute nating spacings. Okay? So, syempre, dapat may mag-hold sa kanya. So, yan yung ating spacings. Okay? So, yan yung kino-compute natin. Okay? So, para mas maunawaan natin siya, so, let's give a sample problem. Okay? So, this is a sample problem from Cusalas. No? So, iyan ko lang. Ipaliwanag natin. Oops. Sorry. Yeah, kalimutan kong sige na nga, ito na lang. Itan ko lang konti kasi mahaba-haba yung problem eh. Okay. So, a plate and a angle girder is fabricated by attaching four 13mm thick angle sections to a 1100mm by 10mm web plate to form the cross-section in figure. The moment of inertia resulting cross-section, so yung binigay ng buong moment of inertia, 4,140 times 10 to the 6 mm to the 4th. If the maximum shear force in the girder is, okay, so ito na yung V natin. So you have there already the V. Determine the largest allowable spacing between the 19mm rivets that fasten the angles to the web plate. The allowable stresses are 100 megapascal in shear and 280 megapascal in bearing. Okay, so this time, dalawa ulit yung ibinigay na criteria. So it means we could have choose ano yung mag-govern sa dalawa. Is it the shear or is it the bearing? Okay? So first, ang formula natin again for the S is equals to the Ri over VQ. Okay? But this time, meron na akong I. Okay? So, you have now the I is equals to 4140 times 10 to the 6. Okay? Ang wala na lang ako is the R. Pero yung V meron na rin ako. So, that's 140 kilonewton. Okay? Wala na lang akong R and then the Q. Okay? So, for the shear, okay? Isang shearing area, no? So, 1 shearing area. Okay, for one shearing area, so yung pinaka-R mo, so that would become equals to shear stress multiplied it by the area. For the shear stress, we can have it, ilan yung ibinigay? 100 megapascal. Okay? And then area natin, pi over 4 multiplied it by ilan? 19 squared. Okay, so you have now the R. So that's 100 times pi all over 4 multiplied it by 19 squared. So you can have it as 28,352.87. Again, this is in Newton. Okay, now we will choose, okay, from the neutral axis. Okay, ano ba, kapag natanggal yung bolts, okay, yun yung clue nyo, no? Pag natanggal yung bolts, hawakan nyo dito, natanggal yung bolts, ano-ano yung mga areas na matatanggal? Okay, so ito yun, di ba? Kung wala yung bolts, tanggal to. Okay? Tanggal tong part na to, at saka tanggal tong part na yun. Okay? So I could have that for this area, no? First, this is the R, by the way, no? R to based on the shearing. Okay? Kaya lang, kapag natanggal yung area mo, okay, ilang shear yun? Okay, ayan, balik tayo sa shearing area, no? Ilan yung shear mo? Meron ka ditong 1 shear, and then meron ka ditong second shear. So, meron kang dalawang shearing area. So, it means, so yung R ko, based sa shear, would become equals to 2 multiplied it by, oops, ano ba to? Yeah. Anyari. Okay. Hindi ko alam paano tanggalin. Yun, ayun. Okay. So, meron kang dalawa. So, 2 multiplied it by 28,352.87. Okay, so this is now that one. 2 times 28,352.87. So, you can have 56,705.74. Okay. Kaya lang, meron ka din bearing. Okay? Ano ba yung bearing ko? So, R based on the bearing is equals to, anong formula natin ng bearing? Bearing stress multiplied by the diameter and then multiplied it by the thickness of the web. Ano ba yung may, let's say, ito yung ano, no? Ito yung plate. Okay? Iyan ako. So, for example, I have here yung plate na yan. Let me draw that. Sample lang. I have to draw. Okay. So, tapos meron ako ditong butas. Hop. Ayun. Okay. So, meron akong bearing doon, no? So, I have there the bearing. So, yun yung R bearing ko. So, pag kinat ko dito, I will have to cut that, di ba? Okay. So, para kang merong, ayan. Okay. Ito yung bearing area mo. Wherein this one is the diameter and this is the thickness of the web. Okay, so that's your TW. Okay? So, yun pala, I can now have here the bearing which is 280 MPa. Okay, multiplied it by the D, which is 19, and then multiplied by the thickness, which is around 10 mm. Okay, this one. Okay, so you can have it the R. Okay, so 280 times 19 times 10. Okay, so that's 53,200. Okay, 53,000 Newton. Okay, so between the two, ang kukunin lang natin, syempre, we will be having yung capacity. So, ito mga capacity to, no? So, it's called capacity. Okay, ibig sabihin, pag sinabi kong capacity, iyan yung lakas ng mismong section, syempre. So, i-design mo siya sa pinakamahinang member. Okay, pinaka-critical. Kasi nung yung last problem natin, ang kinuha natin load. Okay, kapag yung load tinatanong, again, ganun din, ano? Okay, i-design natin siya. Ang pipiliin nating load, definitely, is yung pinaka mahinang load. Okay, so dito ganun din. Para maging safe siya in both shear and then the bearing, pipili na lang tayo dun sa mas mababa. So this time, that is the bearing. Okay, so ito na gagamitin ko. Now, what would be my Q? Okay, ano ngayon yung Q ko? Again, that is the area multiplied it by the Y. Okay. Ilang area ngayon matatanggal? Pipili ka lang, taas or baba. Ano? You just choose up or down. Okay? So, this time, I will choose those two. Okay? So, ibig sabihin, meron akong dalawang area. Ano nga yung area nyon? That's 2630. Okay? And then, multiply ko ng Y. Ayun, binigay na niyo yung Y mula daw sa neutral axis hanggang dun sa centroid ng area. So, you can have it as 536.3. Okay? So, this is now your Q. So, that's 2 times 2630, 536.3. So, you can have it as Q, 2,820.938 times 10 to the 3. Okay? That is mm cube. Okay? Kompleto na tayo. So, we can now have the R, IVQ. So, we can have the spacing is equals to the R, which is 53,200. I is 4,140 times 10 to the 6 all over. Ang V ko is 450. Again, in kilonewton siya. So, times 10 to the 3 natin para maging newton. And then, we will be having the Q. 2820.938 times 10 to the 3. Okay? So, this is now the required spacing for this assembly. Or 140 times 10 to the 6 all over 450 times 10 to the 3 times 2820.938 times 10 to the 3. Okay? So, you can have it as 173.9 0.50 millimeters. Okay? So, this is now your answer. Okay? So, ano yan? Ibig sabihin, kung ito yung angle bar mo, okay, pakita ko sa inyo. If this would be your angle bar, okay, sample, ayan yung angle bar mo. Okay? Habaan ko to para makita natin. Okay? Yan yung angle bar mo. So, meron ka ditong mga bolts. Yan. All throughout. So, yung spacing daw niya dun, okay, at least you have it 173.50 millimeters. Okay? Mas masinsin. Okay? Lesser spacing, ibig sabihin, mas safe yung ating structure. Okay? So, kapag spacing ang tinatanong at sa board exam, let's say merong choices, ang sa choices, letter A 175, letter B 170 mm. Ano pipiliin mo? So, you choose the lower. Okay? Mas masinsin na spacing ng mga bolts, ibig sabihin, mas safe yung structure natin. Okay po? So, that's the problem number 1. I will give you time to copy. Okay, so let's have the example. Figures A and B show the cross-section of two beams that are constructed by nailing together 2 inches thick wooden boards. Note that the cross-sections have identical cross-sectional dimensions. For each beam, determine the largest allowable spacing of the nails that will resist an 8,000-pound vertical shear force. The allowable shear and each nail is 250 pounds. Okay. Same lang, nagkaiba lang ng orientations. Okay, so ibig sabihin sa site pala, pag may mga ganun, mahalaga kung paano siya kinonekta. Okay? So, unahin muna natin yung A, no? So, again, we have the formula. Simple lang naman yung formula natin. Yung S natin is equals to Ri all over VQ. Okay? So, we have now the R already given, So, meron daw siyang allowable shear force. Shear force na yung given. So, that's already the 250 pounds. Again, per nail. Okay? Per nail ha? Per shearing area ng nail. Okay? So, meron na rin akong V na binigay. So, that's around 8,000 pounds. Okay? Ang wala na lang ako is the I and then the Q. Okay? So, check natin So, yung dimensional niya, yung dimension, parehas lang naman yan. Ito is, again, 6. Okay? And then, this one, okay, 6 by, that's 6 by 2. Ito daw ay 12 by 2. Okay? So, this is 12 by 2. Okay? So, ibig sabihin, if this is 6 by 2, 6, okay, lagyan natin and para sure. So, this is 6, and then this is 2 inches, and then 2 inches. So, ilan siya? 10. Okay? So, ito, ganun din ba? Mamaya na natin. By the way, mamaya natin anahin So, if this is 2, and then this is 2, and then this is 12, itong loob, I can have it as 8. And itong labas, again, this is 6. Okay? So, again, to solve for the I, pwede kong gawin, I can now have for the I would become equals to I ng whole minus I ng whole. So, I ng whole is BH cube. So, 10 H cube all over 12. Okay? Minus I ng whole, 6B cube all over 12. Okay? So, I have now the I. So, that's 10 times 12 cube. Oops. Ay, ano yun? Nagpe-play. Wait lang. Ay, sinapong ko pala. Okay. So, ilan yun? Ulit. 10 times 12 cube all over 12 minus 6 times 8 cube all over 12. So, you can have it as 1184 inches to the 4th. Okay? So, meron na akong R and then Q na lang. Okay. Ulitin ko, pagdating sa Q. Nandito yung neutral axis. Ito yung neutral axis sample, Hahawakan ko sa neutral axis. Tapos, tatanggalin ko yung bolts. Ano yung area na malalaglag or hihiwalay? Okay? So, ito yung area na yun. Okay? So, that is the area. Okay? So, yun ang kukuhanan natin ng Q. Okay? So, we have now the Q. Okay? Q is equals to A multiplied it by Y. So, ang A ko is 6 multiplied it by 2. And then, ang Y ko, okay, if this is 6, kasi 12 yan So, definitely, this is 6 hanggang doon. Okay, ima-minus ko yung kalahati. Pero ito, 2 yan, so minus 1. So, this is now my Q. So, 6 times 2 times 6 minus 1. So, that is 60. Okay, inches cube. Okay, so the spacing now would now require me R. Kaya lang yung R ko per nail. Kaya lang dalawa yung shearing area, So, isa dito, and then isa doon. So, I can now have 2. So, 2 multiplied by 250. Okay, and then multiply ng Ri, which is 1184 all over VQ. So, ang V ko is 8,000 at ang Q ko ay 60. So, I have now the spacing equals to 2 times 250 times 1184 all over 8,000 times 60. So, I have now 1.23 inches. Okay? So, dapat daw pala, okay, let's say, pag ganyan yung beam mo, hindi pala yan yun. Pag ganito yung beam mo, ayan. So, every, may nail dito, may nail doon, ayan. Every 1.13 inch, merong kang nail. Okay, ganong kalalayo yung nailing mo. Okay. So, ayan, sa bahay, tignan nyo yung mga beams na composite, ano. So, may spacing, may required spacing yon para makayanan yung composite. Okay? So, check natin for letter B. For letter B, ano. Okay? I will check for letter B. Again, same pa rin ba ng area? So, again, ganun pa rin. So, check natin yung dimension. So, this is 10. Okay? And this is 8. So, 2 and 2. So, this is 12. Correct? Okay, parehas naman pala sila, no? So, if this is 12, this is 8. Okay, so ibig sabihin, ang I same pa rin. Ito pa rin siya. Okay? So, yung R ganun pa rin. Ano lang nabago? This time, ang nababago lang is actually the Q. Okay, bakit? Kapag hinawakan ko sa neutral axis, ano naman yung malalaglag or mahihiwalay kapag natanggal yung nails? Ito yun. Okay, ito naman yung buong area na yun. Okay? So, yun yun. So, ang Q ko, that would become AY. So, ang A ko is 10 by 2. Okay? And then, ang Y ko, again, from the neutral axis, we can have it as 6 minus 1. Okay? Ano lang na bago? So, that is 10 times 2 times 5. So, you can have it as 100 inches cube. So, I have now the spacing equals to Ri. Again, dalawa ulit yung bolts. Dalawa yung shearing area mo. Isa, and then dalawa. So, you can have it as 2 multiplied it by 250 R, and then ang I is equals to 1184. Okay? All over VQ. So, ang V ko is 8,000. Ang Q is 100. Okay? So, let's see. So, 2 times 250 times 1184 all over 8,100. Okay? So, you can have it as 0.74 inches. Mas masinsin. Kapag pala ganito yung orientation, mas masinsin yung requirement ng ating spacing. Okay? So, ibig sabihin, between the two, same cross-section, mas okay yung section A na gamitin. Okay? Mas tipid. Okay? Kasi every 1.23 inches lang yung pako. Pero ito, nire-require niya 0.74. Okay? So, that's how you compute for the required spacing for the fasteners of built-up sections. Sige po. Copy. Okay, so let's have this problem. A simply supported beam 10 feet long. Okay, so drawing na natin. So I have here a simply supported beam. Okay. And then again, you have there 10 feet long. Huwag ko na diyang ilagay kasi mag-drawing pala ako ng shear diagram. Okay, dito na lang. Okay. And then I have there, yan. Okay. 10 feet long. Consists of 3 4-inch by 6-inch planks. Ito show, no? Secured by bolts. Ayun, binigay. This time, ibinigay yung spacing. So, spacing daw is equals to 12 inches apart. The bolts are tightened to a tensile stress. Okay. So, ang ginawa dito, pinaikot to, no? As in, nung pinaikot ng pinaikot hanggang, okay, makompress yung pinaka-plank. Parang makompress siya. Okay. So, hanggang sa meron siyang tensile stress na 18 KSI. Okay. The beam carries concentrated load at the mid-span. So, meron daw akong load dito. Somewhere here at the mid-span. Which causes a bending stress of 1,400 PSI. So, I have now the FB of 1,400 PSI. If the coefficient of friction, ayan na, nagkaroon ng coefficient of friction, ano? If the coefficient of friction between the planks, so sa pagkita niya, di ba, inano nga natin, meron diyang mga, kung ito yung mga, kung ayan yung planks mo, for example, ayan yung mga planks mo, okay, so di ba, nag-slide nga yan, di ba, so meron siyang shear doon, so ibig sabihin, meron ding friction doon, okay, so kung mu mo daw, okay, from the static is 0.3, sabi, determine the bolt diameter so that the shear between the planks can be transported by friction only. Okay. So, alamin natin ano yung diameter ng bolt. Okay. Para ang mag-carry is yung ating friction. Okay. So, unahin natin, no? So, meron ako ditong P. Okay. Hindi natin alam. Walang binigay. Okay. So, walang binigay na P. Okay, so let's try to have the reactions. Siyempre, kung nasa mid-span yon, sabi nga natin, di ba, kakalahatiin lang natin yan. So that's P all over 2. And this is P all over 2. Okay? So, draw na natin yung shear diagram. Yun lang na may mahalaga dito. So, I have now here P all over 2. Wala nang iba. So, at this point, and then on that point, negative P all over 2. And then, ayan, yun. Okay? So, now, we can have also the moment. Okay? So, yung moment natin. Okay, the moment diagram. So, let's have this one. P all over 2 kasi ito ay 10. So, this one is around 5. Ay, ayan. Ayan. Okay, so, this is 5 feet. And then this is 5 feet. So, 5 times P all over 2. So, you can have this one. Okay. Okay. So, ano yung point na yun? So, 5 times P over 2, 2.5 of P. Okay. So, that is now your moment diagram. Alright? So, we have the shear diagram. And then we have here the moment diagram. Okay, ang binigay kasi sa atin ay only the FB or the allowable flexural or the maximum flexural stress. Okay, so with that, ang gagamitin natin is the moment. Okay, from the formula, we can have it FB equals to MC all over I. Kunin ko muna si I. So I is B H cube all over 12. Okay, so you can have it the I. So 6 times 12 cube all over 12. So that is 864 inches to the fourth. Okay? So, ang moment natin, okay, dito, ang FB ko is 1,400 PSI. So, ang moment ko is 2.5 of P. Kaya lang, naka-pound feet yon. So, again, i-multiply ko yun by 12, ano? So, para maging pound inch. So, ang C ko is 6 inches, no? So, mula dito sa centroid, na gitnang-gitna, hanggang dun, kalahati. So, you can have it as 6 inches. And then, ang I, you can have it as 864. So, you can now have the value of P in pounds. Okay, so let's have the calculator. So, 1,400 again equal to 2.5 of X. Okay, times 12 times 6 all over 864. So, let's solve 6720. So, you can have it as 6,720 and then pounds. Okay? So, with that, ang ating Vmax, okay, ilan na siya? So, we can have it as P all over 2 or 6,720 divided by 2. Okay? So, ilan na yun? 6,720 divided by 2. So, that is 3,360. Okay? So, ngayon, may binigay. Okay? Ano yung 18 KSI? Okay? So, merong binigay na spacing. Ayun. So, again, from that spacing, we can have it as, for the formula, S is equals to Ri all over VQ. Okay? So, to solve for the R, okay, yun kasi yung force na dinadala ng isang bolt natin, ano? So, rearranging that, I can have it as S VQ all over, okay, over I. Okay? So, we can have it as equal to the R. Okay? So, check natin yung R. So, we can have it as S, which is 12 inches apart. And then, yung V natin, which is 3,360. And then, ang Q natin, ano yung Q? Okay? Again, i-hold natin sa neutral axis. Ano yung area na matatanggal? Ito, pangit. Ito lang yung matatanggal na area. Okay? So, that would be your area. Okay? So, now, we can have it the Q. Dito ko na lang ilagay. I have here the Q is equals to area multiplied it by the Y. So, ang area ko is 6 inch. Ang sabi doon is 6 by 4. So, 6 multiplied it by 4. So, ito daw, mula dito, is 4. Okay? So, ang aking moment arm, 6 minus kalahati ng 4. So, 6 minus 2. Okay? So, that would be our Q. So, 6 times 4 times 4 equals 96. 96 inches cube. Okay? So, balik ko dito. So, that is 96 Ri. Sorry, Ri. All over SVQ. Tama. SVQ 96. All over the I, which is 864. So, ito pa lang yung R para dun sa isang bolt. 12 times 3,360 multiplied it by 96 divided by 864. So, you can have it as 4,480. Okay? Iyon yung force dun. Okay? So, again, dapat equal yan dun sa friction. Kasi yun yung shear force eh. Imagine mo, let's say dito sa area na to, yun yung force na nandun. Okay? Yun yung R. Okay? So, it means kung hindi natin kailangan yun, ang kailangan natin is by friction only. Ita-transfer niya yun dun sa face. Okay? Again, paano nga natin nakukuha? Yung friction, let's say yun yung tabla. Kung meron ka ditong force or normal force, yung friction mo dito, F is equals to mu N. Okay? Where in the F, that is also equal your R. Okay? So, yun na yung R, yung nag-i-slide. Yun yung sliding effect, yung horizontal shear. That would be the R, no? So, I would have it 4,480 is equals to mu N. Paano ko ba kukunin yung tensile force? So, from the force, para makuha natin, that is stress multiplied by the area. So, stress multiplied by the area. So, equal to 0.3. And then, ang stress daw is 18 KSI or 18,000 para maging pounds, kilopounds per square inch. And then, the area is pi all over 4 multiplied by d squared. Okay? So, with this, I can now have the value of the diameter equal to, so, gawin natin siya sa calculator. Okay, dito ko na lang ilalagay muna. So, that's equals to 4,480. 4,480 is equals to, okay, 0.3 times 18,000 multiplied it by pi all over 4. So, pi over 4 multiplied it by alpha x, yun yung nawawala natin, squared. Okay? And then shift, solve. So, siguro, balik natin sa 0 or 1. Okay. So, you can have it as 1.03. 1.03 inches. Okay? So, this is now the answer for this problem. Okay? So, pwedeng ma-relate yung statics, ano? So, maraming paraan. Okay? But that's the idea of the fasteners, no? So, yung required spacing niya, again, that is just the RI over VQ. Just remember na yung R na ibinibigay, you take note, no? Baka yun ay per shearing area. So, dun sa area na matatanggal, i-check nyo ilang shear yung involved. Okay? So, baka mamaya times 2. Mamaya baka times 3. We do not know. Okay? So, you have to check that. So, that's it for the spacing of bolts. So, we are done with the week 9 already, no? So, by next week, we will be having another topic, which is the deflections of the beam. Okay? By then, I will give you, for the remaining time, I will give you another problem set to be submitted 1 week after. Okay po? So, see you on your synchronous sessions.